everyone, how are you doing today? Today we're going to talk about prime numbers. And this is one of very common legal questions. And so let's just look at the problem. So this is the problem. It says count the number of prime numbers less than a non-negative number n. And it gives us an example. So say the input n is 10, the output would be 4. And why is that? It's because there are 4 prime numbers that are less than 10, and these are 2, 3, 5, and 7. And if you don't know, the definition of a prime number is any number that is only divisible by the number 1 and itself. So for example, number 7, it is only divisible by 1 and itself, 7. It is not divisible by 2, 3, 4, 5, or 6. Okay, so I'm actually going to provide you with 3 different solutions to this problem. There's the naive solution, there's the slightly improved solution, and there is the best solution that I have come up with so far. And okay, so in this example, I'm going to use this little visual aid here where I'm just always going to look at the situation when the input is 20. And so these are the numbers from 1 to 20. So how many prime numbers are there less than 20? Let's think about this a little bit. So there's 2, 3, 5, 7. Is 8 a prime number? No, because it's divisible by 2. Is 9 a prime number? No, because it's divisible by 3. 10 divisible by 2. So there's also 11, 13, 17, and 19. So 1, 2, 3, 4, 5, 6, 7, and 8. Okay, so in this case, the output solution would be 8. All right. And let's just make this screen, adjust the screen a little bit. So we'll come back to this visual aid I have made here later on. But for now, let's look at the most naive solution, the brute force solution. All right, let's see. Let's take a look here. All right. In this very naive solution, okay, I'm just going to gray out everything else for now so it's not distracting us. All right, so now let's talk about the first very naive solution. And so what we're going to do here is I'm going to create an array of prime numbers. We're just going to call this a prime numbers array. Let's just call it like that. And this is actually my very first time to be recording a video while I'm coding along, so bear with me. And what I'm going to do here is, so what this array would look like would be an array of prime numbers like that. So, but first, let's just keep it empty, right? And we're gonna create a variable called I, and I'm just gonna start with 2. And why do we start with 2? Because we know that 1 is technically only divisible by itself and the number 1, but it's kind of a special situation, and most of the time people don't regard it as prime number, so it's kind of an outlier over there, and we're just not gonna think about it at all. And then what I'm going to do is while I is less than n, right? So we're going to look through every single number starting from 2 all the way until it's less than n. And just for the sake of my explanation, let's always think of n as the number 20. So for example, let's look at this table here. So in this situation, we're trying to determine all the numbers between 1 to 20 and trying to see which are the numbers that are prime numbers. Okay? All right. And we're going to actually use a helper function here. And we're just going to call this this helper function is prime. So if I is a prime number, right? Prime numbers dot push I, and then I plus plus. Okay. And what do we need to return? So we always need to think about what we need to return. We need to return, is it prime numbers? No, because we want to know how many prime numbers there are, right? So it would be prime numbers dot length. Okay. Now we let's create the helper function, because we have this helper function here called isPrime. So create function isPrime, and in this helper function we're determining every number starting from 2 all the way until number just below n, which is 19. So so you're going to see if it is a prime number. So let's think about this a little bit. So I already told you that between 1 and 20, we need an output of 8, right? So ideally, we want to create a prime numbers array, and it would say 2, 3, 5, 7, 11, 13, 17, 19. And we say here, count the number of prime numbers less than a non-negative number n. So we do not consider 20 because it's not less than itself. It is exactly equal to itself. And I already told you that 1 is a very special situation, so we don't need to consider it either, right? Okay, so we consider 2 all the way through 19. Let's see. So the easiest way to do this is to go, okay, if I equals 2, is it divisible by only by itself and the number 1? And then, okay, for when I equals 3, is it divisible by only itself and the number 1? When I equals 4, is it only divisible by itself and number 1? And so on and so forth, right? Okay. So we need to create another variable. Just say for let's just call this variable 2, and while it is lesser than I, j plus plus. Okay, and then by definition, if I mod j, and this little symbol here, mod, just means, is it divisible by itself? Is I divisible by j? And if it is, it would equal 0. And if it's not, then it won't equal 0. So for example, 4 mod 2 would equal 0, but 5 mod 2 would not equal 0. Okay, it would equal 1. Let's see. Then return false. So what is this doing here? If the number I is divisible by any number between 2 and 19, okay, so say I is equal to 14. If it is divisible by any number between 2 and up till itself, between 2 and 13, then it is not a prime number, so return false. So for example, 14, is it divisible by 2? Yes. So unfortunately, it is not a prime number. But if none of this happens, like it goes through, if the number, let's say 13, it goes through, is it divisible by 2? Is it divisible by 3? Divisible by 4? And all the way until 12, and we make sure that it isn't divisible by any of these numbers, then it breaks the for loop and we return true. Okay. So now we have what we have in the first most naive solution. Let's see if this works. Okay. let's say console.log count primes 20. Oops. Okay. Oh, sorry. Okay. See? So we have number 8. Okay, let's take a look again at what we just did here. And I think the easiest way to think about this is if we plug in a example. So let's say the example n is 20, right? So first of all, we want to create an array of all the prime numbers, right? So by the end, the prime numbers array would equal to 2, 3, 5, 7, 11, 13, 17, 19. And just to illustrate that that is the case, let's see what happens if we return the prime numbers array. And see, it returns the array 2, 3, 5, 7, 11, 13, 17, and 19. Okay. And then we look at all the numbers between 2 to 19, right? And then, so we start from the number 2. And while this number, then we go from 2, 3, 4, 5, all the way to 19. So while it is smaller than 20, if it is a prime number, then we push this number I into this array. And then I++, and then we iterate through the whole thing. And at the end, we want to return how many prime numbers there are. So return prime numbers dot length. So this is the helper function is prime I, and then we go through from j equals, so let's say I equals 2. And then we go from j equals 2 until j is lesser than I, j++, right? If I is divisible by j, then return false, otherwise return true. Okay. I hope that makes sense to you. Now let's take a look at a more improved solution. And this more improved solution is really just this same thing, but with a slight twist to make it more efficient. So I'm just gonna copy and paste all of this actually. Let's see. Okay. All right, I'm gonna gray out this solution because we're not looking at it anymore. All right. Okay, let's move down. All right. So we're gonna call this count primes 2. And let prime numbers equal, again, to an array, right? But let's think about this. Let us look now at our slightly improved solution, which is just an improvement of our previous naive solution. And the reasoning or logic behind this kind of solution is that we know all even numbers are necessarily not prime numbers because any even number is divisible by 2. So 2 is not, 2 is a prime number. It's kind of a exception to the even number rule. But anyway, 4, because it's divisible by 2, is not a prime number. 6, because it's divisible by 2, is not a prime number. And then subsequently 8, 10, 12, 14, 16, 18, they're all not prime numbers. Okay, so if we put that into consideration, then we only need to use half of the resources of our previous solution because we don't have to iterate through every single number, only the odd numbers. All right, so this improved solution is I just copy and paste it from my last solution, but only now instead of I++, we can do I plus equals 2. And then we actually have to start with 3. And let's just put 2 in here because, as I said, it's kind of an outlier. So we know 2 is a prime number, and let's just start from the number 3. So we only have to check the odd numbers. So we plus 2 to I every single time. So we check 3, and then 3 plus 2 is 5. We check 3, 5, 7, 9, all the way till 19. And because until 19, because 21 would be larger than n, then at that point it's already breaking the while loop. Other than that, we still need the helper function is prime and is prime, but also here we also only need to check for half of the numbers, because we already eliminated all the even numbers, so the even numbers, so we're only checking for the odd numbers, and the odd numbers are not going to be divisible by 2, so we only need to start from j equals 3, and then equally, instead of j plus plus, we can just add 2 every single time, because if a number, say 5, it's yeah, because we don't need to look for if it's divisible by 4 either, because 5, if something is not divisible by 2, then it's not going to be divisible by 4, it's not going to be divisible by 6, so on and so forth. All right, so we only made those very minor changes, and let's see if the solution is the same. Let's see. All right. Seem to have some kind of error. Console.log. Oh, wait, yeah. What happened here? Count primes. Oh, okay. Count primes 2. Okay, let's do that again. And yeah, again, we have 8. Right. Okay, so that is the same. But this is a slightly improved solution, and you can see how instead of like going through every single number, we only go through the odd numbers, and instead of checking for every single j, we only go through like half of the j. So in theory, we just cut our memory by 4 times. So, you know, like 25% of our original memory time, or calculation time. But let's look at an even better solution. Right, okay, so let's, again, I am going to put that out so that it does not distract us, and let's look at the better solution. And this one is kind of tricky, because it took me a while to understand this. I did not come up with the solution on my own. I looked it up on the internet, but I think it's a very interesting solution. So let's just take a look at it. And I want to say that I want to kind of first explain the logic behind this solution. And this logic is actually, once you understand it, is very intuitive. It's kind of the way we figure out if a number is a prime number, the way we did it, you know, back in primary school or elementary school when we were learning math. And that logic is, if you look at numbers between 1 to 20, and not caring about the number 20, because we want only numbers that are less than 20, and then we already know that 1 we're not going to consider a prime number. And if we go through all these numbers, which are the prime numbers? And I already said that all even numbers are not prime numbers, because all even numbers are divisible by the number 2, right? So, except for the number 2. 2 is an exception. So I'm going to mark it in a special color. And let me just put this a bit. Okay, so 2 is the special case. And I'm going to say, okay, highlight it so that we know that it is a prime number. But other than that, okay, 4, 6, 8, all these even numbers, they are not prime numbers. So we don't even need to consider them, right? And then in the same way, don't need to consider, we know that 3 is a prime number because it is only divisible by 1 and itself. It's not divisible by 2, so it is a prime number. But anything that is a multiple of 3, so 6, but 6 we already eliminated. So 9, because it is divisible by 3, it's not a prime number. And then 15, because it's divisible by 3, it's not a prime number, right? And then 5 is a prime number. And so anything that is a multiple of 5 is not a prime number, but we don't have any other than that. So we don't have any more of those remaining. And then, okay, 7. So all the remaining ones actually are prime numbers. And you see we have 1, 2, 3, 4, 5, 6, 7, 8. And that is exactly the solution to this problem, right? Okay, so now that I have used up my visual aid, let's just go ahead and code out the solution. So what we're gonna do here is kind of interesting. Let's think first. So what I'm gonna do is I'm gonna create a thing called a flag array. Okay, so bear with me here and I will come back and explain what this is for. And then we're gonna create a result. Let's not call it result, let's call it count. Count equals 0. So this count is how many prime numbers there are. And currently there are 0, right? Okay, so we start with 0. And at the end of this, we want to return count. So as we go through this, it will, every time we encounter a prime number, it will add 1 to the count. Okay, and then at the end, I'm just going to console.log count primes. And then same, we're going to use the example of when n equals 20. All right. And then we're going to just use a for loop. All right. So in the same way, we are going to loop through every number between 2 until 19. Well, n is 20 in this case, so until 19. And we're going to iterate through the whole thing. And then what are we going to do here? So we're going to do something interesting. So let me explain what this flag array is for. This flag array is going to create an array where if a number is a prime number, it will be represented by a number 1. So for example, let's see, is 1 a prime number? No, so it would be 0. Is 2 a prime number? Yes, so it would be 1. Is 3 a prime number? Yes, it would be a number 1. Is 4 a prime number? No, so it would be 0. Is 5 a prime number? No, so it would be 0. Something like that. Yes, but remember that all arrays start with index 0, so is 0 a prime number? It's not, so it'll be 0 also, like that, so on and forth, so forth. This is just an example of what it would look like, right? So this is what we're going to do. So we start from the number 2, and then we'll iterate it all the way up till 19, and if it is a prime number, we will say flag array of number 2 is equal to 1. So if it's equal to 1, then I is a prime number. And then also, after that, because we already have 1 prime number, the count will plus 1. Also, we need to so how do we know if a number is a prime number? So how do we know to make the flag array of that number 1? That is, if flag array I equals to undefined, then we want to put this in there. And this might not make complete sense right now, but we will come back to it. Let's just finish this. And then we're going to create another variable called j, and then we'll just start from 2 also. Yeah, then we're going to say while I times j is less than n, and then the flag array of I times j is going to equal 0. So when something equals 0, we know that it's not a prime number. So I'm just going to make a note here. I times j is not a prime number. All right. Let me just make sure that I have the right number of curly brackets. Yes, we do. All right. Now let's go back and kind of explain what's going on here. But first, let's run it and just prove to you that this solution works. Okay, let's do. Wait. Oh, okay, I spelled something wrong. 976. Okay, count. All right. Oops, 2 O's, and then. Okay, so the result should be 8. Let's see. Whoops, what do we do? What did we do? Oh, right. It's not a prime number, and then we also need to. There we go. There you go. Okay, 8. All right, now let's come back and kind of explain what's going on here. And I think to do that, the best way to do it would be to, let me put back my numbers. 6, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. Okay, I have to look at the number 1. And then I'm going to highlight them. All right. So flag array is kind of like saying if that number is a prime number, flag it. So we're going to flag it by giving it the value of 1. And if it's not a prime number, flag it with a 0. So make sure it's not a prime number. And over here, I'm just going to do the same thing. So I'm going to flag it with the highlighter yellow if it is a prime number. So so this is the way we do it. We start from I equals 2, right? And then if we haven't flagged it yet, so if flag array 2 is undefined, then flag it and make the count +1. So, okay, we start from 2 and we haven't flagged it yet, so we're going to flag it, and then the count will +1 because now there is, instead of 0 prime numbers, there's 1 prime number, right? So count ++. And then, oops, what happened here? Let j equals 2, and while I times j is lesser than n, flag it with 0, meaning it's not a prime number, and then j plus plus. Okay, well, what's going on here? What we're doing here is essentially saying that, okay, if we already know that a number is, if we already evaluated a number, like the number 2, then we're gonna also look at all of its multiples, right? So 2 times 2, 2 times 3, 2 times 4, 2 times 5, all of its multiples are not prime numbers. So we're removing its multiples, right? Because if like 2 times 2 equals 4, then we know that 4 is divisible by 2, so it is not a prime number, and we are removing it. We are flagging it with 0, so we're removing it. And when j equals, because with j plus plus, when j equals 3, 2 times 3 is 6, then we're going to flag it with a 0, we're going to remove it. So just the same thing as before, we're removing all the multiples of 2, all the even numbers. All right, and then I equals 3. We come back to 3, and it's going to say if flag array 3 is undefined, and we look at 3, yeah, it's not flagged either way. It's neither highlighted nor is it removed, so we are going to go ahead and highlight it, and the count is plus plus because now there are 2 numbers. The count is 2. And then once again, we are going to remove its multiples. So you're going to say if 3 times 2, if it's 3 times 2, then it is not a prime number. But 6 has already been removed the first round, so don't worry about it. 3 times 3, 9 is not a prime number. We're going to remove it. 3 times 4, 12. 3 times 5, 15. Remove it. Okay, and then come back. I equals 4. 4, if flag is undefined, but it's already flagged. We already removed it. It's already flag 4 is already equal to 0, so we're gonna just forget it and then go back. I equals 5. 5 is not flagged, so we're gonna flag it, and so on and so forth. And eventually we come to the conclusion that all the remaining ones, all the ones that are, we're gonna either flag it yellow or flag it 0. We're going to either flag it 1 or we're going to flag it 0. And the remaining ones are going to be, the ones that are flagged 1 are going to be prime numbers. And then by the end of it, we will have the count 1, 2, 3, 4, 5, 6, 7, 8. And then that is the solution 8. So in summary, we came through 3 different solutions, where the first one is the naive solution. Let me we had the naive solution where we just go through every single one of them, and it's 2 divided by 2, it's 3 divided by 2, it's 3 divided by 3, you know, so on and so forth, and it is just kind of not the most efficient way. And then we have the slightly improved solution where we don't worry about the even numbers, so we only have to go through like half of the numbers. And then finally we have the better number, the better solution, where anytime after we go through 2, we eliminate all the multiples of 2, and after we go through 3, we eliminate all the multiples of 3, and after we determine 5, we eliminate all the multiples of 5. And this is, I think, so far the optimal solution, and I hope this video was somewhat helpful to you. Yeah, so I look forward to seeing you in the next one.